This is Cameron Chai from ASOM.com, and I'm speaking to Michael Hashka from Bruker, and he's going to tell us about their micro X-ray fluorescence instrument range.
Bruker starts recently with a new product line, micro X-ray fluorescence. We have here three different instruments. We start with a very small one. In that case, we have a spot size in the range of 0.3-0.5 millimeters. Excitation from top. It will be possible to analyze in that way very small filigree parts, for example jewelry. The value of the jewelry depends very strongly on the content of gold in the alloy, and that can be analyzed with that instrument very exactly with an accuracy in the range of 0.2-0.3%. If we look for the next instrument, then the physics is very similar, but here we have a little bit more comfort. That means we have a stage which can position the sample automatically. We have also here the possibility for a detector with higher energy resolution, which means that, for example, traces can be detected, and also coatings can be analyzed, coating thickness down to a few nanometers. In the moment, the last instrument in this series is the M4 Tornado. Here we have a high-level instrument which has a vacuum chamber, a large vacuum chamber for samples up to 30 centimeters large. We excite here with help of a capillary optic, which concentrates the radiation down to 25 microns. Detection will be done with an X-flash detector, which means high energy resolution and very high count rate capability, and that allows to make a very exact analysis, elemental analysis, but also coating thickness analysis, not only in one spot. Due to the motorized XYZ stage, it's also possible to make distribution analysis, for example on a line or on an area. That means we can make line scan or mapping and have a picture of the element distribution of an inhomogeneous sample.
And that's what the biggest difference is between a micro XRF compared to a standard XRF, is it?
The difference in between a micro XRF and a normal XRF is that in a normal XRF we analyze an area of 2 centimeters approximately. That means the sample should be relatively homogeneous, but typically most of the technical materials are not homogeneous. And the advantage of a micro XRF is that you can measure non-destructive this inhomogeneity of the sample goes in all directions. That means in the plane of the sample, but also due to the possibility to measure coating thickness, you can also measure into the sample and see the inhomogeneity.
Okay, and as far as sample preparation is concerned, you can put a whole component into the machine?
Sample preparation in that case is relatively easy. You can say it's nothing because we measure from top with a very small spot. We will find typically everywhere one area which is relatively flat and can be measured directly without any preparation. That means you can also measure, for example, art objects or forensic objects which should not be changed because you like to measure the art objects as it is. This is a big advantage in comparison to normal XRF instruments.
And what other applications do you find these micro XRF instruments being sold into?
There are different applications. I talked already a little bit about forensic applications, art objects, failure analysis, microelectronics, everywhere where you have an inhomogeneous sample and a distribution of different elements, of different coatings or whatever, it is possible to make this type of analysis. You have to take into account that the spot size is really only 25 microns. That is a third of the diameter of a hair. which is really very, very small, and you can analyze this very exactly.
All right, Michael, thanks very much for introducing us to your micro XRF range of instruments.